All right, let's see, this is 2.5, graphs of functions. We'll go ahead and get started. It's the first day on this topic, so hopefully we'll get through at least half of them. Graphs of functions. Before I begin, we talked about what a function is. Well, graphs can be anything. They can be a circle, they can be a cubic, they can be, sine, parabola. They can be anything, any types of functions or any types of graphs that you want. But functions are graphs that pass the vertical line test. Okay, so a parabola passes the vertical line test, and that's what considers a function. So we're going to talk about functions today, and we're going to talk about graphs. All right? So we'll see how it goes. First of all, an even function. This is f of negative x equals f of x for every x in the domain. We said last week that if you put negative x in and you put an x in, you'll get out the same y. We said it's an even function if it has y-axis symmetry. All right? If it has y-axis symmetry, it's an even function. That was for a graph. If it has f of negative x equals f of x, that's the algebraic definition, All right? And there's a type of symmetry with respect to the x-axis. Here's your favorites type of even function, y equals x squared. Okay? So that function's even, and pretty easy to see why. Moving on. An odd function. F of negative x equals negative f of x. We said x would give you a y, a negative x would give you a negative y. It also had symmetry with respect to the origin. Y equals x cubed is one of those. We said that you could check to make sure it had symmetry with respect to the origin. All right? So we're going to work with functions today, function notation, all sorts of things like that. All right? Got that written down? Odd functions. Good. Suppose f is an even function and g is an odd function. F is even, g is odd. So, complete the table if possible. Well, this says for the even function, this says f of 3 equals negative 5. Well, that means f of negative 3 would also equal negative 5. Because for an even function, f of x equals f of negative x. Okay? So they have to equal the same thing. In this case, they both equal negative 5. Here, g of x. So if g of 3 equals 15, and we know that g of x, that means g of negative x equals the opposite of g of x. So that means g of negative 3 is the same thing as negative g of 3. Oops, sorry. G of negative 3 equals negative g of 3, which will equal negative 15. Now, some people might be able to do it in smaller steps than that, but basically the idea is g of negative x equals negative g of x if it's odd, and f of negative x equals f of x if it's even. All right? Also, if you wanted to map it out, you could. Here's 3, negative 5. 1, 2, 3, negative 5. 1, 2, 3, 4, 5. Booyah! So negative 3, there. 3, negative 5 is over there, so negative 3, 5 is going over there, so it's symmetric about the y-axis. It's symmetric. Here, if you have 3 and 15, 1, 2, 3, you can go up 15. If it's odd, it's going to have symmetry about the origin. So it's going to be negative 3, negative 15. Okay? You can look at the picture. You can look at the algebra. You can look at the points. All kinds of ways of doing it. You just got to figure out one way to answer the question. Okay? That's a good question. I like that one. So to determine whether f is even, odd, or neither even or odd. Here you don't have a picture. This one we're going to go with f of negative x. 1, if it equals f of x, it's going to be even. 2, if it equals the opposite of f of x, it's going to be odd. And if it doesn't equal either one of those, it's going to be neither. How do you do it? Easy. First thing you do, you put negative x into the equation. So I have 7 times negative x to the 5th. Oops, got that in the wrong place. Minus 4 negative x cubed. Now use your algebra to simplify it. F of negative x. Negative x times negative x times negative x times negative x times negative x is negative x to the 5th. Okay? And then you have negative x cubed. So if you have that, that gives you negative 7x to the 5th plus 4x cubed. Then you ask yourself a question. Is that the same as what I started with, the same equation? If it is, your answer is it's an even function. If, however, it comes out with the opposite of the equation you started with, meaning negative, you know, if I mean opposite, I mean negative, then it's an odd. In this case, then it's an odd. In this case, the 7 was positive, it turned to a negative. The 4 was negative, it turned to a positive. It's the opposite of what I started with, so it is an odd function. It has symmetric about, well, it has symmetric about the origin. It's an odd function, so it's not even. Okay? Fantastic. All right, let's try another one. So, determine whether f is even, odd, neither, odd, or even. So, to get started, we can, just a minute, excuse me for a minute. We can, again, first thing you do, you put in negative x. And see what you get. Negative x squared minus 5 times negative x plus 1. Oh, then you work it out. What is a negative x times negative x? Yep, x squared. And negative times negative is a positive, plus 5x plus 1. Is that the same as what you started with? No. Is it the opposite of what you started with? No. So in that case, it has to be neither is your answer. Okay? That's how you do it. Well, if you wanted to, you could graph it out also. We'll try that. All right, so go ahead and get your calculators out. I'm going to type in the equation 3x squared minus 5x plus 1. Let me clear this off first. 3x squared. What was it? Minus 5x plus 1. Minus 5x plus 1. Zoom standard we'll always go to. So I scroll down. Kind of weird, didn't see anything move by itself. Zoom standard. There you go. Does that graph have symmetry about the y-axis? No, it doesn't. It's close, but it doesn't. Obviously, it doesn't have symmetry about the origin, so that's why it's neither. Okay? You can either do it algebraically or you can do it graphically. Makes no difference to me. All right? Good. We're moving on. Sketch on the same coordinate plane the graphs of f with the given values of c. Make use of symmetry, stretching, compressing, or reflecting. Well, symmetry we talked about, that's even or odd. Stretching. Well, stretching is when you take a function, f of x, and you multiply it by a number in front. A f of x. If a is greater than 0, greater than 1, like 2, 3, or 4, it's known as a stretch. If a is between 1 and 0, like a half, a third, or a fourth, it's known as a compression. Okay? And reflection, well, that comes from even and odd. All right. So I'll tell you what we're going to do. First of all, we're going to get our regular graph, the absolute value of x. The peace sign, that's pretty good. So make a sketch of the absolute value of x. Y equals math, number, absolute value of x. I'm just going to put mine on here to give it a little bit more, scale. So there's my graph of the absolute value of x. Now, I'm not multiplying by anything, am I? I'm not putting a number right here. So I'm not doing a stretch. I'm not doing a compress. I am kind of reflecting it, because if I put in the absolute value of x minus a -3, if c equals -3, it actually moves the graph this way 3 units. 1, 2, 3. And, it has a little bit of effect on everything. Oh, that should be at 3. Now, an easy way around this is just to graph it out. Graph them all out and see what happens. For right now, I'll put this one up here. There we go. There's 3. And there you go. If I put in 1, x minus 1, it actually moves the graph to the right 1 unit. So I make a dot at 1, and I'm going this way. Okay? Now, when you graph all this out together on your calculator, it's going to get kind of messy. So you better make sure you know exactly what you're doing and how you're doing it. So 3, I'm going to move the graph. Let's see. I'll use red. If I want to do x minus 3, it's actually going to move the graph this way 3 units. Notice they're all x minus. I kept the x minus there because that's how it works. And there we go. There's the 3 units that way. All right? That's what happens if you graph them all out. The rule, if you have f of x, and you take f of x minus c, the graph is shifted c units to the left or to the right. So this is known as a horizontal shift. Okay? Horizontal shift or a phase shift. However you want to look at it. Horizontal is pretty easy to remember. And that's if it's inside the parentheses. You're asking where the parentheses is? Are you serious? F of x equals, you have to put in an absolute value, well, on my calculator, not yours, ABS, absolute value of x minus 3. There. It's inside the parentheses. That's why it moves to the right 3 units. You can put it on your calculator. I don't think I'm going to. I think I'll wait for a little bit of a tougher one. So that's what I would do, and that's how I would sketch it out. Any questions on that? Okay? All right, moving on. 2x squared minus c. Now we just said if you have f of x, that's your standard graph. We said if you take f inside the parentheses, it moves the graph left or it moves the graph right. This C is obviously outside of the parentheses. So this is known as a vertical shift. When you add or subtract C, it's going to affect the graph vertically. Okay? So the standard graph I'm going to look at is 2x squared, which is a parabola. Actually, the standard graph is x squared. Let me erase that. The standard graph is actually x squared. So if I have the standard graph of x squared, it's a parabola. The point 1, 1 is on the graph, and the point negative 1, 1 is on the graph. That's of y equals x squared. If I put the 2 in front of it, that's known as a stretch with a factor of 2. Because what happens to the y value if I put a 2 on there? But yeah, instead of 1, 1, it's going to become 1, 2. Instead of negative 1, 1, it's going to give negative 1, 2. So it's going to go up a little quicker than normal. Oh, I missed. There we go. And it's going to go up a little quicker than normal. The actual graph, if I were to keep it in blue, is a little wider. Okay? So it goes a little wider. So there. That's stretched by a factor of 2. Okay? There's a point 1, 1 and negative 1, 1. So we see that's a stretch. This C, if I take 2x squared minus C, well, on my graph, I'm going to put in the equation y equals 2x squared. Graph. Booyah. There it is. Now what's going to happen in this graph if I make 2x squared minus a negative 4? You know, if I do the first one, 2x squared plus 8. What's going to happen to my graph? Well, yeah, it's going to shift up 8 units. So the graph that normally was right here, 2x squared, it's not going to move left or right. It's actually going to move straight up 8 units. 1, 2, 3, 4, 5, 6, 7, 8. It's going to shift up 8 units. Now what happens if I change it to, oh, I don't know, 2x squared minus 2? What's going to happen to the graph? Remember, if I'm starting out right here at 2x squared, what's going to happen when I subtract 2? Yeah, it's going to drop the graph 2 units down, the whole thing. 1, 2. There. Then finally, if I do 2x squared minus 4, it's going to drop the graph 4 units down. 4. So, the following observations can be made. If f of x equals x squared, then f of x equals 2x squared gives a vertical stretch by a factor of 2. Vertical stretch by a factor of 2. You don't have to write all this down, but you have to understand what it means. If I go f of x equals 2x squared minus or plus 8, why is that plus 8? It should be plus 4. There. 2x squared plus 4, that's going to give a vertical shift or vertical displacement of 4 units. F of x equals 2x squared minus 2 is a vertical shift of negative 2 units or down 2 units. You get the idea. You got your base graph. You got your amplitude, which is bigger than 2. And you got your vertical shift. So the only thing missing is a horizontal shift. Maybe that'll come up next. All right. Here we go. We got a negative. We got a compress, and we got a shift inside the graph. The base graph is x squared. Okay, I'll give you a few minutes to write this down. The base graph is x squared. All right. I like this. This is good. Delete it. We'll go with regular old x squared. Nice. All right. I don't know if I can do this, but I'm going to try. So if I put the negative in front of it, well, that's pretty good. I took my time. So if I put a negative in front of it, f of x equals negative x squared, that's obviously going to take the graph and do what with it? Yeah, flip it down. Love it. And then, if I put a 1/2 in front of it, it's going to compress the graph so it's wider. It's known as a compression of a factor of 2 because it's 1/2. The point on the graph is going to be 1 and 1/2 and negative 1 1/2, and you get the idea. So it's going to be 2, 2, 2. I'm not too far off. That's pretty good. Negative 2, 2. All right. Now if I take this, negative 1/2, and I take it x minus negative 2 squared, a number inside the parentheses shifts it. Because that says negative 2, it's going to shift it 2 units to the left. I like that. So I'm going to shift it 2 units to the left. 1, 2. There's my new graph. Wider and shifted. If it were to say, if I were to shift it and say, oh, I don't know, f of x equals negative 1/2, parentheses, x minus 3 squared. Well, you see how the c is a positive 3? It actually shifts it 3 units to the right. So I go 1, 2, 3 units to the right. Nice. And we've already got, the x plus 0 squared, or the x minus 0 squared, so that doesn't even count. All right, good. Cruising right along. Feeling good about everything? Any questions? Fantastic. All right, moving on. Sketch on the same coordinate plane the graphs of f for the given values of c. Make use of symmetry, square, all that other stuff. Ooh, the base graph. Well, I'd say the base graph is, f of x equals, I'd go with the square root of 16 minus x squared. That's what I would do. If you don't know what it looks like, well, you have the latest in technology. Punch it out. 16 minus x squared. Graph? Oh, what do we call that graph? Yeah, it's a semicircle. Even though the graph doesn't show it, you have to know that it actually does touch all the way. Okay? It actually goes all the way down. What happens if I put a negative in front of it? What's it going to do to the graph? Absolutely, it's going to flip it. And it's going to go down. Okay? So there's what happens when I flip it. That's what that negative does. It flips it. What about the number in front of c? Well, I'd say that would be a scale factor, wouldn't you? It would stretch the graph, wouldn't it? I would think so. And if c is 1, well, that's not going to change. I've already got 1 in my base graph. That's not going to change. If it's 1/2, it's going to make the graph wider. If you're not sure, go to your graph. Type in another equation. Negative square root. Oh, I don't know where the 3 came from. Sorry. Negative square root of 16 minus parentheses 1 half times x squared. And I have to close off the square root. And since I got more than one graph going along, I went back up to my original line of code. And I'm scrolling back. I'm going to press enter so I can get a thick line. I do that from time to time if I have more than one graph. There, oh, see, it is making it wider. It's compressing it. Okay? Nice. I like that. I knew there's no way I could be able to compress it. Yeah, it is wider. Ooh, what happens if you put a 4 in there? It's going to stretch it, make it skinnier. By compressing and stretching, I mean if you put an imaginary handle on a graph, if you push down on the graph, that's a compression. If you pull up on the graph, that's a stretch. So obviously I put a bar right here and I pushed it down and I compressed it and came up with this graph. If I replace the 1/2 with a 4, well, I should get a skinnier graph, a stretched graph. Delete, delete, 4. Wouldn't you think? Yep. Haha. Look at that. Awesome. Oh, it looks kind of like a, a little smiley face. But you have to know that the graph actually continues on. It goes up here and something like that. Looks like it looks something cool. So it does stretch it. Okay? So this is a compression by a factor of 2. And this is a stretch by a factor of 4. All right? Questions? Fantastic. I'm missing everybody right now. It's very hard where I'm at. I'm actually getting ready to eat my dessert. So, anyway, moving on. If the point P is on the graph of the function f, find the corresponding point on the graph of the given function. I have no idea what this means. Oh! I think I got it. Jot this down and we'll work it out. All right. This means my function is -2 and it equals 4. Okay? So it wants to know what is my new y value going to be if I follow all of these changes to the function. Well, I say let's get a graph. Actually, I want something better than that. Okay? Oh, I know. I'll just go to my calculator. I'll take the graphs off, clear. That gives me a nice grid to work with, as long as it, doesn't go past 10, -10. You guys can use a sketch. That's fine. So my original graph starts off at -2, 4. All right, I'm going to put a dot there. A big red dot. All right. So, I don't know, what do you want to do first? The -3 moves it to the right 3 units, doesn't it? Well, that's how it affects the y values. It shifts the entire graph 3 units. So, if this point was on the graph, it'd be shifted to the right 3 units. So, since I started there, I would shift to the right 3 units. 1, 2, 3. And I would be right here. So far, so good? Well, if you take, well, let's do the half. If I do the half, well, that's half of a y value, isn't it? So I guess I take half of 4. Because I'm going to compress it, half of 4 gives me 2. All right? Then the +3 moves the entire graph up 3. So I go up 1, 2, and 3. So my new point should be f of negative 2 would actually equal 1, 2, 3, 4, 5. I'll have to think about that for a little bit. It looks kind of good. I wonder if you can do it any way you want and come up with the same answer. Because, well, the 3 shifts it. We know that. To the right. This 3 shifts it up, and the half cuts it in half. The question is, which one do you do first? Do you cut it in half first, or do you add 3 to it? I think by order of operations, you go from the inside out. So I think you cut it by a half first and then move it up 3. So I'll stick with that answer until I change my mind. Okay? We should do another one of those, but you'll have plenty of chances to do them on the homework. All right. Explain how the graph of the function compares to the graph of y equals f of x. For example, the equation 2 times f of x plus 3 is the graph of f shifted 3 units to the left. That's because it's x minus the negative 3. And stretched vertically by a factor of 2. Well, it's stretched because a is greater than 1. So it's stretched by 2. Well, this one's not too difficult. 1 is positive. It's going to be shifted to the right 1 unit because you have a minus sign there. Remember, it's x minus c. So c is the number. And it's shifted 1 unit to the right. And it's stretched by a factor of 3, vertically by a factor of 3. Vertically stretched by a factor of 3. All right? So, there's that one. Going pretty good? All right, let's see where I'm at as far as this is going here. Oh yeah, I'm in good shape. Got time for a couple more. All right, explain how this graph is done. This is the absolute value of x. There is no shift. The 1/3 tells you there's between 0 and 1. So it's between 0 and 1. You know it's going to be compressed. Now, compressed means you've already identified it's between 0 and 1. So you say compressed by a factor of 3. Okay? If you say vertically stretched by a factor of 1/3, it's kind of the same thing. You're just kind of using the wrong terms with the wrong numbers. Compressed is the one you want by a factor of 3. Right? So, there you go for that one. Compressed by a factor of 3. What would the graph look like? Well, it'd just be wider. Instead of 1, 1 on the graph, instead of 1, 1, it'd be 1, 1/3. Instead of negative 1, 1 on the graph, it'd be negative 1, 1/3. So it'd be a lot wider. Okay? It'd be a lot wider than that. All right. Let's get one more done. We'll take a look at this, and we'll move on. All right, we'll probably do this one and call it a day. The graph of a function f with domain 0, 4 is shown in the figure. Okay? That means the x values. You can only go from 0 to 4 with closed dots. Sketch the graph of the given equation. Oh, I see. Oh, this is going to be fun. If you have this, which is actually the graph of the sine, well, not sine, but close to it. There. What happens if I have f of x minus 2? That's inside the function, so it's going to go that way 2 units. So you just make a picture. 1, 2. There you go. 2 units. That way and you're done. That's all you do. B is pretty much the same, except you go that way 2 units. C, 2 units. And the whole graph is shifted down 2 units. 1, 2. So that's not too difficult. Shifted down 2 units. F of x minus c shifted. I always put plus a d, and I put this as A. A, C, and D. That's how I remember it. All right? Ooh, a negative in E. A negative does what to the graph? Yeah, it flips it. So it flips the graph. Wait a minute. Did I go all the way around? Oh, I need to flip it, not rotate it. Just a minute. Flip it up and down. There we go. So I flipped it. And then it says it's going to stretch it by a factor of 2. So if I want to stretch it by a factor of 2, I don't know if I can do that on this graph. Let me see if I can. No, I can't. Well, anyway, if I want to stretch it, that means the high points, instead of being at, I'll use a different color for this one. That means the high points would be up 2 if I'm going to stretch it by a factor of 2, and the low points would be down more by a factor of 2. So it actually come down, hit it, bounce, go all the way back up, and come back down. So that's what both of them have to do with, okay? And obviously this one's going to make it, wider. It's going to make it upside down, but it's going to make it wider, okay? Instead of being the high points at 2, the high points would be at 1. All right, so you got to get through 41 odd on this section, which is 2.5. You have the rest of the time in class to work on your homework, which should be about 15, 20 minutes, depending on how it got started. So that's as far as I wanted to get, was 41. And if you have any questions, I'll be back tomorrow to answer them. I think in this class, well, I don't know if the weekend's here or not. But anyway, give those a shot. And also don't forget the online solutions if you need them. Great.